So we said earlier that depending upon the wavelength of the electromagnetic radiation that's coming from the sun, and depending upon the size of the particle and the nature of the particle it interacts with, that energy is either going to be what we say absorbed, and the particle will get warmer. That energy will be transmitted, in which case basically the particle doesn't care it's there, or that particular form of energy will be redirected. And in this case we're talking about the redirection. When you see an object, the reason you're seeing an object is because that light has hit that object, and a certain amount of that light is being scattered or redirected in your direction. Reflected, scattered, that sort of thing. And specifically, the color that we see the light as is an indication of the wavelength of light that's being scattered. Now, if you see an object, like this point says, if you see an object that's white, what's happened is basically all colors of light, the red, orange, yellow, green, blue, indigo, and violet, are striking that object, and basically all colors of light are being scattered or reflected back off. So that's why you see it as white. You're seeing all colors reflected up, off that object. Basically, they recombine, and you see that object as white. I think that is so cool. If you're looking at an object that's blue, for instance, then I'll just kind of go ahead and show you what this would look like when I think of this. A blue object, we'll just make it kind of a sheet of paper. That's blue. And let's say this is my white light. So I'm going to call this red, orange, yellow, blue, indigo, and violet because it's white light. And white light is actually a mixture of all those colors. And let's go ahead and put you over here. The reason you see it blue is that blue, B, is reflected, and that means what's absorbed is going to be the red, orange, yellow, green, no blue, indigo, and violet. I just think that is so cool. If we look at something, if we consider something that's black, the reason it's black, let me make another sheet of paper over here, black, kind of make some, and we have white light shining on it, red, orange, yellow, blue, red, orange, yellow, green, blue, indigo, and violet, white light shining on that black piece of paper, and what comes back is zero, nothing. What's absorbed are all colors of the rainbow, red, orange, yellow, green, blue, indigo, and violet. And that absorption by something that's a black color is why, remember we said that when matter absorbs energy, including light, it heats up. So I just think that is so cool. All right. Objects that are white, I think, like I said earlier, actually they're white because all colors of light are being redirected or scattered off of that object, and they're recombining to make the color, to make it appear as if it's white. So as I've been talking about light hitting an object, the amount of light that we've talked, actually we've called something called the absorptivity, and actually this albedo or the reflectivity is the opposite of the absorptivity. The amount of light that's reflected off of the surface of an object is called that object's albedo. And I believe this would just be just talking about visible light. So